We're going to graph simple rational functions. Let's get down some definitions. First off, a rational function is a function of the form f of x equals p of x divided by q of x, where p of x and q of x are polynomials and q of x cannot be 0. I'm going to start with the basic rational function, and it actually goes with inverse variation, where we're going to have outputs, or y, equal to a constant over x, and we're going to make it the most basic constant 1. So we're going to look at y equals 1 over x, and we're going to start using a t-chart. I've got a lot of t-charts out there because we're getting more complex. When we get outputs and there's an error, start putting in inputs between the error and an integer that you got. Well, notice how we have an error and we've got an integer in front of it, integer behind it. So I'm actually going to plug in a lot of values in between 0 and -1 and 0 and 1 to see what happens around this error. Plugging in inputs between 0 and 1. We plot the points and it comes out to be domain and range will both be restricted. Ooh, yeah, domain and range will both be restricted. Because I can't plug in 0, domain is any real number except 0, and this is how we represent it. Domain cannot be 0. If y never equals 0, we stress that the range y cannot be 0. Let's talk about graph tendencies. First off, the shape is called a hyperbola. Hyperbola. Not hyperbola, hyperbola. We will have a horizontal asymptote, and that gives us our range restriction. We have a vertical asymptote, which will give us our domain restriction. And there's always going to be two symmetrical parts called branches. This is an example of a rational function, and we're going to practice stating the domain and range. Typically, when we get an error, we need to plug in inputs that don't just go after it. We need to plug in inputs that go before it. So when I do my next t-chart, I need to get some numbers before -3, like -4, -5, -6. But I don't quite see the hyperbola. So around this error, around -3, I need to plug in some numbers between -3 and -2, and then -3 and -4. And I see the flatness on this right branch. It flattened out when I plugged in those points. So that means this will flatten out. This will flatten out around the same spot. If I were to put in those asymptotes, it looks like they'd be about here if I could, do that straight. Those asymptotes look like it would run here. Maybe not there. Those will develop our restrictions on domain and range. This input did not work, so x cannot be -3. For our range, let's check out that horizontal asymptote. That horizontal asymptote ended up being around what number for the y-axis? -1. So y cannot be -1. Let's talk about a strategy to get these t-charts a little down. And it comes from, could we have noticed that x could not be -3 from the get-go? What would have told us x could not be 3 from the beginning? If we zoom in on that denominator and we figure out what could make that 0, that's going to give us our error. And we can center our t-chart around that. So in our next example, we're going to look at that denominator, figure out what would give us that error, and then figure out how can we adjust our t-chart. A denominator cannot be 0. So I'll center my t-chart around what makes that denominator 0. 1 will make that denominator 0. So I'm going to put 1 in the middle. And I'll put the numbers around 1. It almost looks like our natural guesses of -3, -2, -1, but this just helps us center it better. I start to see the butterfly wings, or I start to see the hyperbola, but not exactly. I am going to have to pick points to plug in around in between 0 and 1, and then 1 to 2. I don't know if we clearly see where, I think we get where the vertical asymptote will be. I think we see that, but where, my graph is not as accurate. So how would we be able to guess where the range never meets? If I plugged in -10, it may get really close to a number. And if I plug in +10, it may get closer to a number. So that is an option. So if I plug in +10 and -10, I might be able to see it a little bit better. So if I keep plugging in really small inputs or really, really big inputs, what would both of these round to? So let's go back to domain. Domain references where we got the error, that vertical asymptote. We got the error at 1, so x cannot be 1. And range represents at what point would we never reach as an output. And if we can't see it clearly, plug in big and really, really small inputs and see what it would round to. So y would never equal 2.